Again, looking at 95, looking at the integrand, I don't know if it's easy or difficult. It really depends on what the region is and if I can integrate that. And what I'm going to say is the region is, they say it's a square and has these vertices over here. So again, I'm going to cut to the chase and look at a picture, and then we'll talk about what I'm seeing in the picture. And I should be seeing those points in the picture. So what points am I looking for? Well, I'm looking for the points they listed. And there's 4 points, and they say it forms a square if I connect those 4 points together. They're vertices, by the way. This is going to be 2, 1. This is going to be 1, 2. This point over here is going to be 1, 0, and this point over here is 0, 1. I can put the lines down now for you, and this is going to be y equals. Looking at the slope of that is going to be 1, so I'll say x, and the y-intercept is -1. You probably should check it with the points, by the way. So 2 minus 1 is 1. It certainly works for this point, and it works for this point here. So that looks good. Now let me put this line down over here, and that's going to be y equals. The slope of that looks like, you know what? Let me stick to a different line. I want to be more consistent here. Easy ones. All right, let's do this line over here. Y equals, the slope of that's 1, and the y-intercept is 1. Does that work? Well, 1 plus 1 is 2. It works with this point. And 0 plus 1 is 1. It works for that point as well. Let's do this line over here, and that's y equals. It's got a negative slope. I'm going to say -1, so minus x. And what's y-intercept? It looks about 3. Let me just check it out. Does it work with 2, 1? It does. Does it work with 1, 2? It does. All right, let's put this line down over here. What do you get? Y equals. And I got to be careful here. It's a negative slope, so minus x, and the y-intercept is just 1. Does it work with 1, 0? It does. It gives you 1, 0, and 0, 1 works as well. All right, so I'm going to write these a little bit differently. And the reason I just wanted to see if I can go back to the key and look at that, and hopefully I see those things over here. So if I were looking at this one over here, I would basically just say, oh, x plus y equals 1. That's what I'd do there. All right. So if I were looking at this one over here, I'd say x plus y is equal to 3. Right? And let's see if I got this one right. And this one will be x plus y. You know what? I made a mistake here, and I just saw it. It's going to be x minus y is equal to 1. Sorry about that. So x minus y equals 1. Let's put this over here. X plus y is equal to 1. And then there's one other guy I got to do. Got to do this one over here. And I'm going to say x minus y equals -1. Okay? So I got 2 things to look at. I got, x minus y, x minus y, x plus y, x plus y. So I'm going to stick with those 2 and make a substitution with those 2. Let me go back and see if that's written down, though. I notice sometimes I write a key with mistakes in it. So, x plus y equals 1. Let me go back over here, and I want to emphasize that I have that written down somewhere, and that's right over here. Okay, x plus y equals 1. Do I have x plus y equals 3? I got that right there. Let's keep moving. Do I have x minus y equals -1? Right there. And do I have x minus y equals 1? Let me see if I have that written down. Yeah, right over here. So I got them all. And I notice there's 2 things I'm really looking at. And so I need to make a statement over here, like a different variable. So I'm going to say u is equal to x plus y. And then I'm going to say v is equal to x minus y. Now, the reason I like to do this is it allows me to come up with some kind of an expression for x and y in terms of u's and v's, by the way. So I'm going to add them together. So u plus v is equal to 2x. So x would equal u plus v over 2. All right, see if that's written down. And I think I made a mistake somewhere. So x plus y and x minus y, add them together. I get 2x, u plus v over 2. Let me see if I did that right. Yeah. So there's a mistake here, and I got to correct it. This is actually x. All right, let's do the next one. And I'm going to do u minus v. What's that going to be? X minus x, and then you can get 2y. So u minus v over 2 is y. All right, this is y. All right, so what I'm going to do now is I'm going to put the Jacobian down, and let me get my eraser out. I'll make corrections of my notes later, by the way. And let's see if I put the correct Jacobian down. A lot of times these are just typos. It's easy to say that, but I think it's a typo. Let's write the partial of x with the partial of u. And I'm looking at this over here. That's going to be 1/2. Let's look at the partial of y with respect to v. And what's that going to be? Minus 1/2. The product of this thing is going to be minus 1/4. Do I see that? Right over here. Let's do the next one. And the next one's going to be the partial of y with respect to u. Let's see, partial of y with respect to u. That's going to be 1/2. And then I got to put down the partial of x with respect to v. And what do you get there? Partial of x with respect to v, 1/2. So what's the product over there? It's going to be 1/4. So let's see if I did that. I did. And what do you get there? Minus 2/4, which is minus 1/2. The absolute value of that's 1/2. So what do? Again, I do need to make a correction, but I got to write this down. All right, so let's put this over here. And the original integration is written over here. And what do? I put the dA down. And what's that going to be? It's really the 1/2 du dv. Let me talk about the limits of integration. And for the u, I'm looking at it, and the u is really just x plus y. The u is x plus y. So that means it's going between 1 and 3. That's where x plus y is going between. So I see that. Now let's talk about the v. What's the v going to be? It's y minus x. Where's that going between 1 and minus 1? I see that over here. All right? So I got to do other things. Do I know what x plus y is in terms of u's and v's? Let's write this down, x plus y. And I got to write it over here. Oh, it's squared. I'm sorry. I got to put that down. So x plus y. Whoops. X plus y, and we got to square that. So I'm going to add these two together. 2's common denominator. And what do you get there? You just get 2u, right? So that's going to give you u squared. I definitely see that. Let me outline that for you. What's the next thing I got to do? Sine squared, and I got to get x minus y. Let's write that down. So it's going to be u, let me write it down for you. X minus y. That's going to be u plus v over 2 minus u minus v over 2. What do you get there? Coming out of 2. U minus u is none, and you get 2v on top, so it's just v. I'm definitely following that. All right? So then the question becomes, is what are you going to do now? That's a good question. What are you going to do? I would pull out a half, by the way. I'll write that down for you. And then I write minus 1 to 1, and then I write 1 to 3. Let's see, u squared sine squared v du dv. Let me outline what I'm going to do now. I'm going to do this over here. And that looks like an easy integration to do. I'll put that down for you. So I'm going to get u squared, I'm sorry, not u squared, u cubed, sorry about that. U cubed over 3 sine squared v, and that's going to go from 1 to 3. And I'm evaluating the u. That's going to give me, let's see, u cubed, 3 cubed is going to be 27, and 27 minus 1 is 26. I'm going to write that down. I'm going to pull the 26 thirds out. What do you get? 1/2, 26 thirds. The integration I'm getting now is from -1 to 1 sine squared v dv. I got to do that now. All right, before I do that, I want to make a simplification. 2 goes into 2 once, into 26 13 times. So I get 13 thirds. Let me erase this over here and write that down. Okay, so what do I got to do now? I got to integrate that sine squared. I just got to remind you, a lot of times you can't really remember every detail, but we've seen these before, by the way. So let me write this over here, that the cosine, I'll write this over here, the cosine of 2 theta was 1 minus 2 sine squared theta. So I'm going to say 1 minus cosine 2 theta over 2 is the same thing as sine squared theta. All right? So I need to write that down. And you're going to get 13 thirds. Let's see, -1 to 1. Let's see, 1/2 minus cosine 2 theta over 2. Boy, that looks nasty, doesn't it? Oh, not 2 theta. What am I saying? Got to pay attention here, right? So it's cosine 2v over 2 dv. All right? Let me get rid of that little scratch work on the side. Before I do it, I want to carefully look at it. And, yeah, I think I'm okay. I think I can get rid of this too, by the way. Kind of old information at this point. Kind of moving forward. So what do you get over here? Let's take a look. Whoops, I didn't mean to do that. 13 thirds. Antiderivative of 1/2 is going to be v over 2. And the antiderivative of the cosine would be, let's see, sine, right? So sine 2v over 2. When I differentiate that, I would get, cosine 2v times 2. So I got to put a 4 here. Let me just check that. And if I differentiate that, I'd get cosine 2v times 2. Yeah, I think I did okay. Limits of integration are going from -1 up to 1. I can put this down now. 13 thirds. Let's see, I start with the v now, right? So it's 1/2 minus cosine of 2 over 4 minus, I'm going to do -1 now, minus 1/2, and then it's going to be minus cosine minus 2 over 4. I'm going to keep moving through that. 13 thirds. 1/2 minus a minus 1/2 is going to be 1. And I get minus cosine of 2 over 4. And this is an even function, so I can just write this down as it's going to be now minus cosine of 2 over 4. I got to stop for a moment and think what I just said, though. And this is going to turn out, let me get my little eraser out. Yeah, I'm pretty comfortable with that. So what are you going to get over here? 13 thirds. 1 minus 2 cosine 2. So it's going to be cosine 2 over 2. Let's take a look, see if we got it. Now, I'm going to say they did something here. I guess they did a common denominator. Let me look at that before I commit to it. A 6. 3 times 2 is 6. You can get 13. This is going to be 2 over 2, by the way. And 2 minus cosine 2. Let me look at that. Oh, they multiplied it out. So 13 times 2 is 26. Oh, they factored out a -1 too. That's kind of odd, right? But anyway, you could do that. Let me write this down for you. It's 26 minus 13 cosine 2 over 6. If you factored a -1 out from this, I'm not sure why I did that. It would be 13 cosine 2 minus 26 over 6. And that's the answer they have listed. So yeah, we're good. All right? Is it a tough question? Yeah, they're tough questions. Thank you for paying attention.